Okay, so before we get to the meat of the conversation today, a couple of announcements. One, there is a link to a AAAF implementation survey in the agenda. This is a brief survey, and it is for people who are implementing AAAF at their institutions, people who are thinking about AAAF in their institutions. And if you haven't and you want to tell us why, what the hurdles and things are stopping you from doing it, we'd like to hear that too. Multiple people can respond from one institution, so don't worry about duplicating your colleagues' efforts. The more, the merrier. And then upcoming events, in addition to our community calls, we have our 2026 online meeting happening January 27th through 29th. We'll have a whole bunch of lightning talks and lots of workshops and trainings. That is free to attend, and you should be on the lookout for registration for that to start in December. And then our 2026 annual meeting is happening June 1st through the 4th. It says Leiden. That's where our conference days will be, but we will be kind of hopping around the Netherlands for the week. So we'll have our free showcase event happening in Amsterdam. Then we'll take the 9-minute train ride over to Leiden for a couple days, and then we'll meet up in The Hague for workshops and trainings on the 4th. So be on the lookout for the call for proposals for that. We'll see. Maybe we'll get it out before the end of the year, but I think probably early January. Okay, and with that, I'm going to turn it over to Greg Weideman to present DadoCM, Delivering Archives and Digital Objects, a conceptual model.
Hi, everyone. Thanks for Caitlin for setting this up. I'll go through I've done different versions of DadoCM talks to different communities, so I have some stuff at the top that I'll go a little bit fast through, but feel free to call things out at the end. And then I'll dive into more of the delivery side, which is kind of, I think, particularly notable for this space. So I'm going to talk about delivering archives and digital objects, a conceptual model, or DadoCM. And first, I'll kind of talk about what we're trying to accomplish with this work. We have an IMLS grant doing work, what we're calling the ArcLight Integration Project, and that's really trying to address the problem that most archives have two different discovery points for their materials. Digital and physical materials often have separate systems and experiences. Digital repositories don't really fit archival descriptive practices, so we end up having to describe our physical and digital collections in one system and then upload our digital objects in another system, and these systems don't communicate that well. So we need to better integrate digital objects with archival description in archival systems, and this is kind of what this might look like. Was our implementation before this work, where we had our archival finding aid system in ArcLight, and we had this bento layer on top is on the left side, and then we had a Hyrax digital repository which had our digital materials, and those linked together, but depending which bucket you get different experiences, and we at least try to put this bento layer on top so you would have a single search bar that searches everything. But in most places, you'll have like an archive-based implementation and an asset management system, and it's very hard for users to navigate. And it's also really hard for archives to kind of manage the metadata behind the scenes. That's because archives use aggregate description is what we call it, and that's based on ISAG and DAX, which is the American implementation of ISAG, more or less. Instead of describing things one by one, we describe materials in large groups or in meaningful aggregations, basically. And there's lots of flexibility for archivists to use our professional judgment in making those groupings and things. So thinking those groupings might be like a file series or a collection or even a file. It has a bunch of items in it. So a file is also an aggregation. And we try to describe the context of the materials. And those descriptive fields are inherited through what is often displayed as a hierarchy, but is really like technically a graph. So our metadata looks structured kind of like this, where you have collections made up of series, made up of files, made up of also items within them. So different points in this might have different levels of detailed description. So all of these collection series of files, DadoCM uses the language of archival components, which is a thing that EAD does. In archive space, they're archival objects or resources, depending on what level you have, but they're essentially kind of the same metadata interconnected, basically the same records, but interconnected. And really our metadata inherits. So basically the series has the same fields as the collection unless those fields are overridden. So this is really efficient because we can we can describe some materials without really detailed description, and then some materials which may only get accessed maybe once or twice a decade. There might not be worth the effort to make them more discoverable. So we can have, even within the same collection, a lot of flexibility to use our professional judgment to kind of handle both of those use cases. And this is because archives are kind of at the edge of the documentary record. At least in theory, the stuff that we don't collect gets lost. So we want to make that as expansive as possible. So if we focus more effort on a smaller amount of materials, there's more materials that will be lost. So this helps us really be efficient with that effort. And DAX has a lot of good language to say, to make user-driven decisions here. You could always add more detailed description if there's a good user-driven decision reason to do so. The main problem is that our digital repositories, our digital asset management systems do not think of metadata in this way. They generally use individual metadata records. They might have one level of hierarchy. And this often causes archivists to redescribe when they're digitizing materials. So if we have a process collection that has using aggregate description, if so, you want to digitize a file from that, you might not only have to do the actual scanning, but you might have to actually redescribe and create a Dublin Core or mods record to upload it in your asset management system. When sometimes when archives are trying to do more and more digitization on demand or on request, that material was sometimes already discovered by a user, so it kind of shows that it was discoverable enough to be discovered. And then we're redoing work in a lot of cases that we don't want to do. And this approach does not, in particular, scale well for board digital materials. So if archives get a disk image or a hard drive of materials or unstructured board digital records, something like that, you're never going to really go through file by file or even folder by folder and create Dublin Core records. There's a lot of duplicate work if you do that, and it's not the right approach for this. So our aggregate archival description works really well for board digital systems, but our systems of managing that material on the web does not. So AAAF is really advantageous for us in addressing this problem, is because it allows the interoperability we need, that we can provide our access through our archive systems that handle that aggregate description and archives metadata, yet we can do the content delivery through AAAF. And this is really cool because it allows, you can either do it directly with a AAAF image server, or just through a static, even potentially static web server, but it also allows compatibility with a variety of systems, since AAAF has been really widely adopted. So you can use your existing asset management system as the content delivery side of this equation, kind of. So it really allows archives a lot of flexibility. So a lot of this work is centered on what archivists call digital object records. And this is something we've done for a while, at least since the early 90s, where we're linking to digital objects from finding aids or from our archival description. And we generally call these digital object records, but we've never had a standard or common guidelines for digital object records. DAX, ICIG, EAD, no one really makes good content standards about what a digital object record is and what it's trying to accomplish. And archive space, this is really reflected in archive space because when it was implemented, there's never really a clear plan. So a lot of things got in the archive space digital object record. So you can have both historical notes like description attached to digital objects, but you can also have technical metadata like checksums. You can use these for a variety of different use cases, and that means that it was implemented among archival repositories in really inconsistent ways. So if you can compare different repositories and look at all of their digital object records, they'll be widely different and trying to do widely different things with the same kind of model in archive space. So one of the barriers to doing this work is that we need a common model to actually build some sort of system around to do these integrations. So as part of our work, we funded these ArcLight integration project cohorts, which was a competitive process that we were able to solicit practitioners that really do this work on the ground. And we took applications and we weighted towards, we had an area where you could state that you're a member of a protected class, and we weighted participation towards BIPOC representation in particular. As being like underrepresented in the field. So we had a 20-person remote cohort that we met over a course of a week in December 2024 to do structured remote exercises in small groups around what are we trying to accomplish with digital object records, and start to tease out like what do we need to accomplish to do this work. And then we brought a subset of that of 8-person in-person cohort here to Albany in February of this year for a series of working meetings to develop what became DadoCM. So we used it kind of our approach to conceptual modeling is a little bit different than I've seen implemented elsewhere. Mostly, we think structured data is really good, but not all data deserves to be structured because we have to acknowledge that our profession is in a resource deficit. We and all data complexity has a cost. Um, we don't want to structure to the point where it becomes more complicated to implement that we're never actually don't have the resources to actually develop implementations for that data. Another thing I think, since our resources are not equitable, this is and there's an equity component to this. If we make our data more complicated, it advantages better resources to institutions and not less resources to institutions. So we're not trying to model all possible permutations of what a digital object record could be. We're trying to find the simplest possible digital object record that can fulfill a variety of our use cases. So we're trying to find this sweet spot where we cover a lot of these, but it's still very practical for technologists to implement. And I think when we do conceptual modeling, it has to be built in conversations with systems designers and maintainers. This kind of emerged through this process, this idea. So we didn't really at the start try to solicit a participation from like archive space maintainers necessarily, but we had enough overlap with folks that are really embedded in those spaces, including some of the people who were involved in the original archive space development and stuff like that. So like, it sort of by accident, we kind of had this already in a cohort. So this became delivering archives and digital objects, or DadoCM. It takes the word from a dado, which is like a woodworking term, which is really fits about like kind of slotting our digital objects into our archival description. And it's a high-level conceptual model focused on the connections between archival material and the digital manifestations of those archival resources. And it's really focused on how do we deliver digital objects through our archival description. Although we wanted to do this work to implement it in ArcLight, this is really system agnostic. So the hope is that this could be implemented in the archive space public user interface or in a variety of systems. And it should scale up or down to really sophisticated, complex implementations, and then down to small repositories that you can have very basic implementations using like commercial cloud storage and like basic web servers and things like that. So we wanted to really scale up and down. So we've kind of part of this process defined what a digital object record is trying to accomplish. So we've basically said a digital object record tells us where to find digital objects, characterize the nature of what digital objects are, tell us how a system should render them for delivery, and also why they may not be accessible. So some of the principles around this work. First, we focus particularly on access over management or preservation. Managing and preserving digital materials is definitely an ongoing concern. And that was one of the things that if you look at an institution's digital object records, they might be trying to like have like pointing at different versions of content for preservation or management purposes. We're kind of scoping that out and saying that like, yeah, you might want to do that. But what DadoCM is concerned with is really on the access side. So the management preservation is a really hard problem to solve too. But the hope is that if we like get some more structure and standardization on the access side, the rest of our procedures will eventually kind of funnel towards that. But also there's just a lot of complexity and uncertainty about how, and we wanted to leave a lot of local flexibility to how institutions manage their content. So DadoCM is not opinionated on how we manage digital objects necessarily or preserve them. But some of the principles is that we want to manage archival description of our digital objects without duplicating work. We don't want to re-describe materials, but it might not be necessarily in one system. And this is where things like IIIF, the interoperability part, can really help us out. We also want to maintain a connection with our archival component because in practice, even here about 10, 15 years ago, we scanned a bunch of photographs, for instance, from a university photograph collection. We kept those photographs in our archival collection, but since our systems didn't really communicate in this way, and we didn't have this work done, we created like Dublin core style like metadata records for each photograph and uploaded it into an asset management system. So the connection between that was lost. So although we can find and search and find those images and they're back in our stacks in our photograph collection, we don't know what box or what folder they're in, for instance. And this is a common use case around archives that are kind of managing this problem. So we don't want to do that anymore. We want to try to maintain some sort of identifier or some connection with that original archival component. And we also want to describe and provide aggregations of digital materials at the point where they become self-describing. So we don't want to take an entire born digital like hard drive or something and describe every single little thing. if a user can actually navigate that original folder structure, that might be we might just give them the whole like data as a whole and let them navigate it essentially. So whatever the user can use it, or it is self-understandable and navigable, that's the point that we want to hand it over to the user. We promote IIIF as a way to do this, but it really allows METs or like simpler approaches, like just a PDF or put it in a zip file too, because we want to scale down to really small implementations. So another thing we kind of mandated as part of DadoCM is that digital objects are manifestations of archival components, so they have a one-to-one relationship. This doesn't necessarily mean digital objects have to be one thing, because archival components themselves, like a series or a file, are also aggregates, so can be digital objects. So when we're talking about digital object here, we can be talking about groupings of things, and this pushes the kind of onus for delivering that grouping of thing onto IIIF or other technical solutions towards delivering aggregate digital objects, which we think is the correct way to go here. This is a little problem. This kind of a problem for archives is because we haven't had this level of standardization. We have a lot of historical data that doesn't maintain this one-to-one relationship. This is really helpful because it helps us to clarify what's the metadata and what's the thing that we're describing, but it poses some practical challenges, especially around digitization. So like, what if you have a big folder and you only want to digitize part of it, because scanning the whole thing might take a couple hours, but you just want to scan part of it to serve a user request. Basically what DadoCM offers some recommendations. It basically says you can scan only the part and deliver to the user, but if you really want to maintain that digitization of the archival component, you should scan the whole thing. And then you can use your professional judgment on where that scale in those cases. It does propose we have this problem of a CD with a folder of paper records. So we do have some theoretical problems here, but that's kind of where we don't want to fulfill every possible use case. We want to scope it back to where we make some compromises here to make it really easy to implement this from a technical perspective. So yeah, we don't want to have multiple digital objects because it blurs the line of what's description and what's the thing that we're describing, and it adds a lot of substantial complexity. If those different types of records, it's not clear about where the boundaries are between them, it's hard to build systems around. So that really makes DadoCM kind of aspirational for some archives that have a lot of legacy metadata. So this is going to take time to address, but I think this is stuff we do. We have to clean and maintain our data all the time. So I think this is part of our regular work anyway, but hopefully by putting this target that we want to get to, it helps archivists make these decisions over time. We also have a lot of descriptive metadata. So what DadoCM also says is that our descriptive metadata should really live in our archival components and not in our digital objects. But we also have a lot of digital objects with legacy descriptive metadata. So it really says that this is a kind of a legacy problem that we hopefully don't need to do in the future, but we actually handle it. We don't want to discard all that existing descriptive metadata that is so really useful for us. So we also make some recommendations like, for now, just use a key value field attached to digital objects. That's a thing that IIIF can support and carry that metadata along to our archival systems. Maybe in the future, we migrate that metadata, but that depends on the individual cost benefit of those cases. So this is what a DadoCM digital object record, these are the fields of that record. We have an archival component relator, which just means like maintain the relationship with the archival object. An identifier, which is like a URL, URI, which that must be retrievable. So how do you actually get the thing? A label, so this is for a simple implementation to just linking to a thing. So you might need some human readable text to like render that link essentially. We have these two fields, type and action, which I'll talk a little bit about more, and that tells what a digital object is and how to render it, how an access system should render it. Conditions governing access. So this is like if you want your digital objects behind a login, for example, we need to have some sort of machine actionable data there. A representative sample, which could be a thumbnail or a clip of a restricted video, for instance. And this is also extensible. So when you make your own local implementation, you could of course, add your additional fields. So this is meant to be flexible. So going into those type and action, we made some recommendations like you could use MIME type, you can use DCMI types, but really you just have to use some sort of controlled vocabulary. So type might be, this is a IIIF manifest, this is a PDF, this is a work, this is an image. And action is embed or link. So like typically something like that, where it tells an access system, like, do you just want to link to a thing or are you trying to embed it within the access system? So some examples, we can just have embed in IIIF manifest for if you want to embed IIIF viewer. embed an image, link to a PDF, or even embed a work file, which is some really cool implementations that we can do following this path. For conditions governing access, what we kind of figured out is like we need some metadata here, and this is actually a conditions governing access note in DAX or ISAT-G. And we're really leveraging here, DAX says notes can have dual human and machine representation, so we're kind of suggesting that approach. For example, like some digital objects that might require a login. So this is so it can carry that through to your access system, so you can like facet on what materials are openly accessible or what might be behind the login. So DadoCM doesn't actually make any recommendations about where to store this material. So that's up to local implementations. So for our implementation, this is just an example of some of the utility we're using behind the scenes. This is a very simple like JSON model. And these are kind of how we implement it. So we use some extensibility to like add some specific metadata and some text content that's carrying through to our access system. But these top fields are data that lives in archive space, particularly. These bottom fields are fields that IIIF is really equipped to kind of carry for us. So what we're kind of doing is using that identifier to get the manifest, parsing the manifest, and getting them this information out of the IIIF manifest for our implementation. Yeah, so our implementation is live now at archives.albany.edu, and it's cool in that you can have digital art objects and full text search in the same system. So if we poke out for a bit, I can do a quick demo. I switch Cuomo a lot for demos because he comes up, both Andrew and Mario come up a lot in our collections. So this is an archival system. So you have like an archival finding aid, you have collections and then materials within them. This is ArcLight, but then we also have digital objects within these too. So we can facet by only digital objects. And what's really cool here is that we get, metadata records and then connected to their context of creation, just like archival discovery paths really want to do. But also in here, we carry that full text metadata, the full text search. So not only that it prioritizes things that are in the metadata, but if we search down, we have just a file here that's minutes from it, and there's actual text here that talks about Cuomo here. So then you can actually display the digital object within that archival context. And this is some minutes from our university senate, but this got picked up in the discovery search just because of the full text here. And that's also, there's a transcript of that where we extracted the text here. So I just want to kind of conclude by talking a little bit about the materials that we're talking about to delivering, because I think that's particularly useful for the IIIF community. So we're talking about here both digitized materials and born digital materials. And this is mostly different because digitized are more consistent. We're controlling that, we're creating them as the archival repository. So they're generally more consistent and there's not a lot of need for additional context. Born digital is where you get a lot more surprises. There's a lot of potential technical metadata and context that we can either use or not use depending on each situation, and you just get a lot more surprises and a lot more variability. We also have a long tail. So this is the resource type from our access system, where most of them are documents. These are all the digital materials that we deliver online. Most of them are documents, images, periodicals, bound volumes, like a yearbook or something like that. But it also scales down into some weird edge cases, and then document in particular can look a lot of different ways. But then we have like web archives and some other things that will get harder and harder to deliver through IIIF in particular. So we have the easy stuff, things like digitized images from a bound object. That's like a yearbook. This is like, they're much more regular. This is pretty easy to do in a manifest. Periodicals, digitized video and audio, because we're normally treating them as individual files at that point. That's pretty relatively easy to handle. Then we get things that are a bit harder. Digitized images from a folder. You just might get some variability within the folder, that there might be like order might matter, things like that, but that's still a thing that IIIF does really well right now. Born digital AV files might have a little bit more complexity than digitized AV files, but still IIIF is really good at handling that. And then we get a bit harder. We get consistent and uniform born digital accessions that we hope we get. An example that I'll show is that we have a USB drive of photos. That's a pretty good use case, or like a small web archive, like a capture of a single page in a work file or something like that. And then you get some really the hard stuff. There's like some hard drive or disk image, who knows what's on that material, so how do we deliver that? We have one use case that we have an XML export from a WordPress site that we only got the export. We weren't able to capture some of that materials in the Wayback Machine, some of it's not. So how do we handle that? Or larger web archives that can have lots of different things in here. So some of the things that we can do, I think again, IIIF really is a really great use case for delivering materials. One other use case, we have these yearbooks and we scan them at pretty high resolution, which is really great. This is a really great yearbook from 1962 that our student association kind of disavowed because of the kind of protest nature of it against the Vietnam War. So it's a really good like kind of historical document. And when we delivered these over a PDF with a high resolution, took a lot of time to load and things like that. But we have like the deep zooming of IIIF. It makes these really much more accessible where we get our resolution on demand and things that are it's much easier, much better user experience. So that's a really good fit. Another thing that IIIF really allows us is alternative representations in manifests is something that's really helpful for archivists, particularly for born digital materials, because we can have a representative image that we can deliver immediately, and then we can have alternative content. So here's an example here of a born digital file. This is a PowerPoint presentation where we kind of had a conversion to convert it to PDF and then extract the images from it. So we have representative images from the slides. So you get a kind of at a glance view, but then if you open up in Mirador, the alternative formats, you get a text transcription, you get a PDF, you get the original PowerPoint. So if you want it, if that metadata from that original Power PPT file is useful, you can also get direct access to that. So associating these multiple versions is a really another use case that I think IIIF is really well equipped. This can get a little wonky though. Like we tried to do it with like spreadsheet data. Okay. So we get a representative image of a spreadsheet that may or may not be useful. You could imagine if the viewer was prioritizing different things, this might be a useful use case, but really what you want is probably the CSV down here. So this is not a really great example. It's a little wonky, but it allows us some flexibility in having that functionality. So I think for archives, we even want to center our alternative representations even more. So examples like that. So the image might be just kind of what you look at first, where the main delivery might be the alternative format. So this is really useful even when IIIF viewers don't really add much. So this is an example of a web archive, a very simple like work WAC-Z for this kind of mixed collection that protest collection that we did that we rendered. So this is not using Mirador because we're using replayweb.page, which is a client-side, does client-side rendering of web archives. So we're embedding that in this page. But what is really useful is that we have to carry a PDF version of this page and then the transcript, the text data to our access system. So the manifest is really useful for this. Our implementation, actually, this is kind of quick and dirty the way we did this the first time, doesn't use a manifest, but we're planning on redoing that and using a manifest, even though the manifest, it's not going to be delivered still through the manifest, is that it gives us a way to like carry on that text, get it into our index so it shows up in search results. So when you search this, and this is another instance where even the PDF is useful because this is a website, our student newspaper that uses Wix, which is terrible to web archive. So it's really hard to get these images in the capture. Only some of them get through. So you really prefer a web archive, but you can view the PDF and that shows all of the images. Kind of, it's both of those representations have some sort of merit and none of them are kind of perfect. So we have a lot of use cases in archives like that I think IIIF can really be helpful with. And also include some technical metadata alongside it. So that the manifest still, even if we're not delivering through an image viewer, is really helpful for us to kind of carry that data from the digital object. Another thing that's really cool, has a lot of cool potential, is using IIIF collections for nested digital objects. So IIIF collections you basically just have groupings and you can kind of nest them. So Columbia has this example through these two examples they've customized Mirador to do this, where in this image viewer, you can have a folder and then you click through, it's another folder, and this is using IIIF collections and you finally get the actual thing. So you can see if that example of a hard drive or some sort of like unstructured, you could do a lot with this without having to describe individual folders and files. This is the same kind of principle within ArcLight. And we've kind of experimented with this. This is an example from Occupied Wall Street. So we got this thumb drive from the organization in charge of maintaining the park. So they were maintaining Zuccotti Park. So they have a lot of um, like photographs from Zuccotti Park and the Occupy Wall Street. So you can actually use these collections to kind of these are the folders that were on that thumb drive. This is a much more simple born digital accession that you can kind of go through and flip through. And these individual photos might not merit really detailed metadata, but you can kind of give it the access to the thumb drive as a whole and just kind of describe it as a thumb drive and deliver it as a thumb drive and have the user use these original folder headings to kind of navigate, which is a really cool use case. This is a little wonky on the edge cases, mostly because like collections aren't prioritized in image viewers this way, so the usability is still, there's a lot to be desired there. But I think there's a lot of potential there. We also need support for that kind of long tail, and we're not going to deliver every content through triple F viewers in particular, but things like PDFs would be really useful because for documents, a lot of times we can batch them to images, but for born digital PDFs, sometimes images don't really aren't the primary delivery way we should be delivering them. So I know Columbia has an implementation where they just use the browser's viewer of a PDF and then carry that through the manifest. Also for arbitrary unstructured stuff that we're not actually delivering, maybe just let the users download the thing. So that's a common use case we have in archives. So that would be a really great functionality to have. So remaining kind of viewers, I think we need some more consensus about how to do this in a manifest. If we have arbitrary formats at different different canvases where users can download them, things like PDFs it'd be really useful to have a consensus around how to do this. Potentially more structure for alternative representations where we can add some like context to them, like so they're not all weighted equally in the UI necessarily. And then better viewer improvements, whether there's specific viewers for our use cases and archives or extending existing viewers, like better usability for our alternative representations and better support for nested collections if that's really useful. So the next steps in our process, we're going to publish Dado 1.0 as a Git repo and static website. So we have a website up here, dadocm.github.io, but it's very much in the draft form. It's still the same thing that's in the Google Doc, really. So we're kind of taking in the feedback we've gotten over the past couple months, and hopefully in the next month or so, we're going to publish a 1.0 version. We need to improve Archive Space's implementation of DadoCM, so we're working with that community to kind of try to figure out common patterns to implement in Archive Space. We also have an open RFP this month for an Archive Space to ArcLight plugin, so we can kind of help that pipeline. And it will do what we're doing in our implementation at archives.albany.edu is that we'll use manifests to pull digital object records and pull the full text into our access system for better discovery. And then we still want to engage the IIIF community more on these needs for archives. Is there ways we can propose like examples or there are already examples that exist someplace and how we should do these implement these use cases in IIIF? And that's it. So thanks very much. And thanks again for Caitlin for setting this up. I'd love to talk more about like how we can use IIIF to better deliver archives and special collections materials.
That sounds great. I think we can definitely get some archives people together to communicate on this. But right now, I'm going to open the floor for Q&A. If you don't want to unmute and you want to type your question, I will read it out loud for you. But if not, and you are comfortable unmuting, you can do that as well.
I'll throw some links in the chat that might be helpful too.
Yeah, Zachary.
Hey there. I haven't been to a IIIF meeting before, so this is so all exciting to me. I sometimes I don't know if a question is appropriate for IIIF or for ArcLight about this like topic, but I'm wondering how everyone is thinking about the topic of using technical metadata for discovery with this model. Because I really like seeing the born digital examples that Gregory you were showing. And I think that there's like just really great potential for using discovery for technical metadata to help users discover material in a different way.
Yeah, I'm not necessarily sure. In our use cases, we've had very simple examples where, but I think there's going to be some things where we can utilize a small, we're going to have like a long tail of things where we might be able to use more common patterns for some things, but for many things, we're just going to have to deliver the materials, kind of the original source materials, and hope that provides some context too. But I think it definitely is case by case.
Thanks for commenting.
I'm
Other
curious if those who have been more involved in the triple F community than I've been, like have these use cases come up before? As I'm very kind of curious about if there's like history or backstory about questions about delivering PDFs, for instance. Like, have there been debates in the community about is there a good reason not to do this? Stuff like that.
Yeah, jump in, Richard.
Yes, I'm very interested to see this, especially with your exploration of collections, because I have found collections very useful for expressing how archives work, and the whole idea of whether something is a collection or an object, and it often depends on how the thing was organized in the first place. And when you've got quite a large collection of collections, you find different collections have been organized in different ways. But I think to come back to what you were asking about AAAF, I think possibly the question is how far you can stretch the concept of a canvas, because of course a viewer has to have a canvas. And I was wondering, for example, are you going to put a whole PDF on a canvas, or are you going to translate each image of each page of a PDF, if it's a page-based PDF, onto a canvas? Or does it in fact just make sense to drop into a PDF viewer and sidestep AAAF and use AAAF for its strengths? And just bear in mind that at the moment, some things just aren't used in AAAF situations.
Yeah, I think that's a good point. I don't have a clean answer. I know Columbia's implementation, what it appears to do is have a whole PDF as a canvas, and it does it within Mirador through a plugin that it just uses the browsers. So in this example here, if you go down into the nest, there's a lot of PDFs, and it just uses whatever native browser within Mirador to display it. And then it begs the question of kind of like, do you even need Mirador then? So yeah, and I think you could do what we're doing with web archives too and just use the viewer, but I think the manifest itself like still has a lot of utility in like providing some structure for how an access system can like embed and view it. But yeah, I think those are things that I'm not confident that I have the answers to too, but I think there's a lot of cool potential.
Yeah, I think one of the other areas, of course, is whether you find it again in the same place when you look in a year's time, which is the interesting thing, because I really like the example of how to deal with a whole thumb drive of photographs without doing too much work, which I think would appeal to anybody who's sometimes you get a big file of photographs, you think, well, I'll just present them to people. And other times, as you say, you have to go down and deal with each photograph individually and put a label. But it may well be that somebody else, because it's in AAAF, will come along later and do that for you because it's out there. And it doesn't have to be the person publishing the AAAF images who is the person who ultimately provides the interpretation, cataloging, etc. of it.
Yeah, that's interesting to think about.
Yeah, just want to note that Brittany said that generally provide the PDF version as an alternative via the rendering property. So I think Brittany's talking more broadly about CRKN.
Yeah, and that's what we're kind of doing currently for most use cases.
I'm pretty interested in the slide that said structure for alternative representations. A few of us have been talking about providing structured kind of like markup representations of images using annotations. And then I think the AV group is talking about how some annotations provide accessibility features to AAAF manifest. So I'm wondering if this is talking about the same thing.
Awesome. Yeah, I'll definitely be interested to, and I'll look into what other folks are doing.
Cool. I'll message you on Slack maybe with
Awesome.
the documents.
Yeah, we'd love to know. Yeah, our main use case has been like for born digital materials, especially PDFs, like as an alternative rendering. Sometimes the PDF is like a derivative format for digitized materials or something, or sometimes it is a born digital PDF. And to kind of convey that meaningfully to users, we just literally put in the string parentheses original after some cases. That is not an ideal implementation.
Yeah, Richard.
Yeah. Have you looked at Universal Viewer? I don't know whether I dare mention this in the presence of Mirador, but obviously the design principle behind Universal Viewer was that whatever you come up with, you can see it in Universal Viewer. So it might cope with things that maybe IIIF isn't quite expecting.
Yeah, when we originally, I think there is a work cycle going on or something too. So when we originally looked at viewers, we were using Universal Viewer in our Hyrax implementation prior to this work. The reason we went more with Mirador because it did a little bit more of the nested collections, at least had a minimal. It still, I think, was very boilerplate-y, or it feels that way to me. And that I don't know if the developers really knew a lot of use cases. They're like, throw it in there maybe. So it wasn't necessarily perfect, but it was like, oh, this is something that's an approach. And also like having plugins, like it has a path for extensibility, but I don't think you're wrong in that. We wouldn't be against trying to figure out, because then it begs the question of like, where is the funding and resources and the labor for developing and maintaining things? So we're open to any viewer. It's more of like, we want to create a community that this can be done sustainably one way or another. Yeah, thanks for that example too of rendering a PDF as images.
Okay, any other thoughts or questions? Going once. Okay, then maybe before I wrap up, Greg, what is the best way if people want to talk more about archives or particular use cases? How should they reach you?
I don't know actually. Maybe we've had some minimal discussion in the Mirador channel of the IIIF Slack. I think there's an archives channel. I don't know if
There is, and it could use an injection of fresh energy. So
yeah, so maybe that is and I don't think I've been active in that space. So this I'm noting to be more active, and maybe I'll post the slides there as a kickstart.
okay, that would be great. This is recorded, so if you miss some of this or you have other people, colleagues or other folks at your institution who might be interested, it will be available on the IIIF YouTube, and I'll also share the recording in that archives channel so that if you think of things later, there's a central place for you to put those thoughts. I'd like to thank Greg Weideman for his time and thank all of you for coming. We have meetings coming up in December. We'll skip January for our online meeting, and I hope that we'll see lots of you there. Bye, everyone.
So long.